right, we are live. Just to let you know, Dawid.
All right.
Let's wait a couple of seconds for everyone. All right, so I think we can slowly start. So, hello everyone. Welcome to the first Functional World event of the year. And actually, I'm pretty excited about today's topic and that we are kicking off the year with cybersecurity subject because I think it's very important one, not only for Scala developers, but actually for anyone aiming to build secure software. And this time we'll have a special focus on Docker and Kubernetes with insights from Dawid Jóźwiak, who is our Scala system engineer. And he has been actively sharing his knowledge and expertise with our team internally, but also externally during some meetups. He also shared his knowledge on our blog. So if you would like to read some of his articles, you can just check out our website. And well, I hope you will like today's meeting and today's talk as well. This is the first time for Dawid at Functional World, so I'm keeping my fingers crossed for you. And before I wrap up my short intro, a quick heads up for you guys. We are hiring like crazy at Scala. We have several open positions right now, not only for Scala devs, but also for Kotlin, full stack, and other positions. So maybe you are considering a fresh start this year. So you can consider Scala, and you can just check out the details on our website. Or you can just wait a couple of minutes and I will share all the links in the chat, so keep an eye on it. And well, that's it from my side. And Dawid, once you're ready, I think you can start. Thank you.
Thank you. All right, let's start. So today's topic is secure development, and we will talk about two topics, Docker and Kubernetes for cybersecurity. That's the agenda for today and nothing more, but still, it's a lot. So to start with, I'll introduce myself. I've been working in IT for 6 years, and my specializations are cloud, cybersecurity, and infra. From the particular clients I have worked for with AWS, so directly for the big cloud guys, and I have plenty of insight from the in-house, let's say. My approach is quite practical. I don't believe in the clutter or gatekeeping of many words, just minimalism, just what's necessary. And as a fun fact, I bought my PC, my first PC in 2003 by saving money. And not long after, I started hosting game servers. That's how I learned databases. It was different technology than what we have today, but it was plenty of fun and gave me a lot of hands-on experience. So, diving in, let's talk about what is Docker and Kubernetes. Many of you may be familiar with the definition, but I'll just say that quickly to ensure that we all are on the same page. Docker is basically a platform to create, deploy, and run your apps in nice, light containers. It provides consistency in your development. In short, it simplifies your workflows, packages your apps with dependencies, so you don't need to keep doing it over and over and over again. And Kubernetes, on the other hand, is the platform to orchestrate all of it. So you have Docker containers, and you can have many of them orchestrated in Kubernetes to ensure that they scale, they're always available, and they have efficient resource management. So you don't need to do it yourself or by hand or by some scripts. Basically, you can compare Docker to an individual music player in an orchestra and Kubernetes to the orchestrator, to the person who says what tone to play and so on. And how is it relevant for functional programmers and the functional world event? Well, Docker and Kubernetes in cybersecurity aligns quite closely with your principles, which is predictable and reproducible behavior by the immutable infrastructure that Docker provides, and also by environment isolation to ensure that your builds and your deployments are reliable each time. Also, it empowers you to have team collaboration since you can version them and share them. And by them, I mean images of the applications that you use. And also, since it works in sandbox, isolating all the dependencies and everything, it secures the development pipelines for you. That's a lot of nice things in a small package. And why Docker? Well, as I've mentioned, Docker uses isolation. So it runs in a sandbox environment, minimizes the risk of cross-contamination, dependency conflicts, or anything leaking out to your host system, if done properly, of course, which we'll get into. It's also guaranteeing you some reproducibility, since it ensures that your code works identically from development to production, from staging to development, from development to staging. And it's also lightweight and efficient. It uses way less resources compared to traditional virtual machines that we are used to. If you still remember VMware or some other machines, that's much less to compare. Also, it has many things out of the box when it comes to security. However, it's not fully secure by default, and for production, additional configuration is required. So while it's nice, it's important to keep in mind that you will need to tinker with it before it goes live. Let me just check the chat. Okay, nothing yet. All right. So let's talk about some basics of security in Docker. A good practice and one of the best practices is to use minimal and well-maintained base images. My personal favorites are Alpine and Debian Slim. They have the bare bones everything that you want and desire for creating an application. Everything else you can list up in Dockerfile, and during build stages you can just add up as you need. And this ensures you have only the stuff you want, only the stuff you trust. And let me tell you something, the biggest mistake that many developers do is just pulling random containers from, let's say, Docker Hub and running them as it is because they are convenient, or because maybe the name matches up with what they need. Maybe it's a Postgres container from Bitnami. Well, Bitnami are good guys, but still, it's always nice to have your own Docker image. And by pulling random containers, you might end up in some trouble. And I will explain that after this slide. Next, regularly update those base images that you have. So you have this Alpine image, and ensure it's regularly updated and it doesn't lack in security patches. The second biggest mistake of developers that I've seen there and there is to run containers as a root user. So basically giving them admin access unnecessarily. Those containers can be exploited and they can access your host system. That means your computer or the server that the containers run on, or other containers that run in parallel to those containers. Depends on how much privilege the system has, of course. Last but not least for this one is to sign your images to ensure they're authentic and integral. So basically, like you sign your applications and so on with trusted certificates. This one you can sign with some software like Docker Scout and some others to ensure that whoever downloads or uploads your Docker image sees its signature and sees that it's authentic. And this signing process can be used in later orchestration with some special rules. For example, you can enforce that containers without a signature cannot be allowed into the environment. This is pretty neat. As for the thing I've spoke about, to ensure that you have the trusted images and keep them minimal and to not run them as a root, well, let's take a scenario. Let's say an attacker breaks into a privileged container, a root container. Well, they can bypass this container isolation because containers run in a sandbox, and they can use a rootkit to remain hidden in the system and also to gain some extra privileges. In the worst case, they can use a kernel exploit and they can gain full control over the entire host. So once again, your computer or the server that hosts, well, the virtual machine or the dedicated physical server can be taken over by an attacker, and you will not even be aware of that thanks to the rootkit. So yeah, that's pretty serious business. So how to build secure images? Well, one thing I would recommend is to make them multi-stage. So to separate build dependencies from runtime environments. This not only reduces the container size, but also the exposure to vulnerabilities, since we have less dependencies to deal with. As an example, you can build a Python application binary in the first stage of building and then copy it over to a lightweight runtime image, for example, Alpine, just like I mentioned in the second stage. This ensures that the Alpine runs your compiled application, and everything that was happening in the build stage is discarded and not used anymore. This is a very good practice. Next thing is to keep your secrets. So this is a big one, and I've seen it pretty often. Kind of sad, but well, I guess it's the reality when we have to hurry with projects and rush like crazy. Well, never hard code your credentials, keys, passcodes, whatever in Dockerfile or image layers. This is pretty much environment variables that can be pulled up, and if compromised, well, can lead to nasty things. It's much better to use Docker secrets, but still an even better option is to just use cloud, like AWS Secrets Manager, which is very, very, very hard to breach into if used properly. And this is the way I would recommend. Of course, there are equivalents for Azure and Google Cloud, so whether you use this or that doesn't matter. You will always have some secret store, or even HashiCorp Vault if you prefer that, but that's as many tools as you want in the market. And how to maintain those secure images? Well, a good idea is to keep them in check with stuff like Docker Scout to detect any vulnerabilities within their dependencies. Docker Scout, I've mentioned before, it's a very, very beautiful tool, and it will be your friend in many application builds with Docker. And then once you have it scanned, you can keep monitoring them and analyzing what happens during their lifecycle from the build into the deployment with tools like Falco or Sysdig. They're open source. You don't need to pay any giant fortune or any cent at all to include it into your own process. The next thing, of course, is to isolate your containers. So the bridge, overlay, VLAN within the Docker network, and to not expose the network, the host network, unless absolutely necessary. They should have their own virtual switch. And also, encrypting your container is a very good idea to secure the communications. If you want to even go deeper for some large-scale applications, you can use service meshing. It's very popular, and there are tools like Istio for that. But this also can be handled by Kubernetes later on. And this is an example of how a simple Docker multi-stage looks like. In the first stage, we are building the Python application, and in the second stage, we have it copied over and running from the base Alpine image. All right, let me just check something. Nothing on the chat. Oh, I see something on the chat. Yes, this presentation will be available for download. Also, you will have contact to my LinkedIn, and you will have links to my blog post and blog posts, actually, many of them. And I will be available during the next days and maybe weeks for you to ask all your questions you want on LinkedIn. If you are just watching this from a recording, or if you are curious about something in chat, or maybe are running low on time. Thank you for the drop. All right. And these are some small tricks how to boost your runtime security. So the first example is what I spoke about, running them as a non-root. Here we add a user and we run the entire container as a simple app user. We can also make the file system as read-only, so nothing can be written or executed from it. We can also limit the resources, so it only uses like half a gig RAM or 1 core of the CPU. This is pretty handy. This can be handled also by Kubernetes, but depends on your scale. You may not even want to use Kubernetes and want to keep it locally tested so it doesn't clog your entire RAM on the computer. And also you can restrict its capabilities. So for example, it can only bind a network, or it can only access to somewhere, or maybe not do anything. So with this cap drop all, you basically destroy all capabilities from it, and then you add individually what you want for this container to do. And this is also a very, very good practice. All right. And this is a big one, Docker Scout. It's a free tool. It's developed by Docker guys by Red Hat. And it uses simple syntax to scout for CVEs, so the very big critical vulnerabilities. You don't want them, and you can scan any image you want, whether downloaded from Docker Hub or made by yourself. It will check anything and compare it to the database of that. And also there is the SBOM command. You may be curious why there is this SBOM command. Well, SBOM stands for Software Bill of Materials. And in short, it's a detailed inventory of components, dependencies, libraries, and everything else included in container or application. And why is it such a big deal? Well, SBOM is required in some certificates like ISO 27001 or the federal ones like FedRAMP in the US, or even the Executive Order 14028. And those last two things I've mentioned, the FedRAMP and the Executive Order, well, if you are not compliant with those, then you are not allowed to cooperate or work with government entities or high security agencies in the US. So if you are a software house or a freelance developer and you do not meet those, your contract can be either terminated or they will not even consider partnering up with you, which is a big deal. And well, do you need it? Yes, as I've mentioned, it's for passing the certifications in some states and also perhaps in some European countries. And also scanning helps to find even more vulnerabilities that, scanning with the Docker Scout can find you vulnerabilities, yes, but SBOM lists the details of each dependency for you, and it helps to keep a track of inventory of what you have, and then verify its integrity, check its origins, and so on. You can backtrack everything thanks to the SBOM. So you have those two nice comments. You have the entire help documentation here within the Docker Scout. I really recommend playing with it and giving it a try since it's free. And there is even a handy web version that I really like. However, if you have confidential projects or something else, then you can use it locally in Docker Desktop and nothing will leak out. Let me just check. All right, all is good. And here is an example of how running Docker Scout looks like. Here, after executing the Scout for CVEs for Postgres image 13.1, yes, I know that's an old Postgres. We have detected 10 vulnerable packages with a total of 17 vulnerabilities. They are marked with 1C, 4C, 2C. What this basically means is they are critical, high, medium, or low tier vulnerabilities. As we see here, there are 17 critical tier vulnerabilities, and that means not good at all. And that's why it's much better if you really need this outdated Postgres version to just bundle it up in your own Alpine or Debian Slim image and do it your own way. And some trivia, as I've mentioned about FedRAMP, your production image must be shipped vulnerability free, otherwise those very serious states agencies will not even want to work with you. And since containers share the host OS kernel, any security breach can affect your computer. As a reminder, never pull images randomly from Docker Hub or QA.io or anywhere, even if those sites are trusted and very popular. Many of those images, while not malicious initially, they can be outdated. You just take a look at some of those and see that they were updated 3 years ago, 2 years ago. They are working fine, yes, but they could and likely do contain unpatched vulnerabilities. So always scan before pulling them, and especially before executing them. And that would conclude the Docker section. Let me just check comments again. All right. All clear. Let me just mention that since we are jumping into Kubernetes, you don't always need to use it, because we have something like Docker Compose for local development and small setups. Kubernetes is more like if you want to automate, if you want to scale, and if you want to go for production or larger environments. But let's slowly delve into it. Basically, Kubernetes allows for container orchestration. So automates your scaling from 1 to 5 containers, deployment, a new version comes out, developers push out a new version, or maybe you just push your own version and it automatically deploys everything from the CI/CD into the infrastructure and slowly rolls out the old Dockers contained by this Kubernetes and replaces them with new version, ensuring that they transit in a nice, no incident and no outage way. And it also works by managing them across multiple environments. So if you have dev, you have staging, you have production, this is a very good tool to use. Also, pods, just like Dockers, and also from Kubernetes namespaces and network policies, they can help you to isolate even further and ensure that the attack vectors are limited in your infrastructure. And there is some nice thing that many tools don't have, which is self-healing capabilities. So whenever an application dies, let's say there is a memory overload or there is a critical error that is unpatched from the application itself and the machine hangs and so on, the container will die at this point. But since it's self-healing properties, the deployment that you have set up, or even the stateful set that you have set up before, will restart those pods and they will scale back to, for example, 2 out of 2 backend services still running. So this will ensure that they'll always be up and running. And also there is something very neat called role-based access control, or RBAC in short. It's basically allowing you to set what container, what pod can do what. Since it's native, you don't need to really add any tooling to manage those permissions in there. There is also secrets management, and you can even automate your own TLS certificates, so you don't need to do them by hand. So once again, this will not replace Docker. Basically, it uses Docker like in an orchestra, many musicians and one orchestrator doing its leading the way there. And since we use Dockers, of course, every basics for Dockers would still apply to the individual images contained within Kubernetes, but there are its own security basics. For example, using namespaces to separate the environments, like development and production, to limit resource access, and also to prevent cross-environment interference. So anything that happens on development doesn't really touch the production environment, just in case somebody runs some shell script or whatever in there. And the RBAC can be used to enforce the famous principle of least privilege by assigning roles to users and services based on their actual needs. So once again, admins shouldn't be omnipresent, right? If this container only serves to communicate with backend, then so be it. It doesn't need some middleware access. It doesn't need anything at all other than the communication with backend, and that's where it should stop. There is also the secrets management layer in Kubernetes. You can store sensitive data like API keys, credentials, and everything else, and to store them in there and restrict access to those with RBAC, so that particular services and things do not access those unnecessarily. Let's say you have a backend API key and a front-end service for some reason would like to access that backend API key. And well, if you set up RBAC properly, it will not be allowed to because it doesn't have the proper service role. Then you also have network policies, which allows communications between pods and external networks. So, and it allows to control those communications by defined rules and restrict unnecessary traffic. So since we are connecting to the outside internet, we don't want to, just like in classic networks, we don't want to open too many ports. We don't want to, well, let's compare it to a firewall, to just block out everything you don't want in there. There is also pod security standards. I believe it was called pod security admissions in Kubernetes 1.24, but since 1.25 it has been dropped, and well, we are already at version 1.32. So let's follow pod security standards. They are used to enforce safe configurations with very simple security policies and to disallow privileged containers or writable root file systems. Plenty of many things to remember, but plenty of things to remember, but all of them are very important. And since I've mentioned pod security, and this deserves its own section, As I've mentioned, you can restrict certain operations such as running as an admin or using host namespaces. Here are three commands that you can use to restrict an entire namespace, production in this case, with three parameters to, for example, enforce. So block pods that don't meet the restricted standards. That's a very strict one. To audit, so to log violations without blocking, and to warn them, to issue warnings for non-compliant pods, but to still allow them. Well, this last one is nice for development or maybe for staging, since it's likely not going to be exposed to the internet and the customers or whoever is not going to use it. You don't really need to go strict on the non-live environments in there. Let me just check. Well, honestly, I've seen people using Podman and giving up on Docker. I've seen people concerned by Red Hat stance and other company drama like Terraform with HashiCorp. There was this, I know it's not relevant to the Docker and Kubernetes, but companies can change their minds and can change the system in how they distribute the open source, or maybe how they set up maintainers and maybe put more strict controls, or maybe even make the model paid. I believe Docker is very safe to use and still very future-proofed. Sure, it's good to be aware and I think trained in using alternatives in case something pops up. But personally, in whether I'm using small scale or large scale environments, I always go for Docker. But one thing I don't recommend doing is using Docker Swarm. It's non-relevant. It's basically Docker Swarm is basically a meme at this point, to be honest with you. But Docker itself, oh, it's viable. And the amount of support it gets and the amount of the sheer size of repositories like Docker Hub and Quay.io, it, well, makes your life easier as a developer or especially as a DevOps. So yes, there are alternatives. I believe it is good to be aware of them and to be trained in them, but I would still stick to Docker in my opinion, because it's going to be there for the next 10 years for sure. All right, so we were at the Kubernetes pod security. Let's go into network segmentation. Yes, I know those screenshots are packed, but this is just to show an example. And if necessary, I will just post or do something after to showcase those things in detail. But basically, those network policies can be used to define traffic flows between pods and, for example, something else. So pods are denied by default, and for example, you can allow front-end pods to communicate only with backend pods. This is basically what these two snippets do. So we want the backend and front-end to communicate, and we basically set that with ingress. And this is pretty useful. When should we use it? When should we use network segmentation and what network policies? Well, in my opinion, always, because by default, if we do not use network segmentation with network policies, those pods can communicate freely and can do all kinds of weird stuff. All stuff we don't expect, and especially if we have an intruder or somebody with extra access, we don't want them to mess with those pods. And those network policies let us define rules for both pod to pod. So for example, front end to backend, but also pod to external traffic. So when our pods are reporting to outside, like to Apache or Nginx or something else, or any other outside service open to the internet, then there will be much less headache in case of any potential breaches or vulnerabilities afterwards. And also, going by principle of least privilege, those pods should only communicate with what they are meant to communicate. So front-end with backend, I don't think front-end needs to communicate with, let's say, one doesn't need to communicate with. Well, it's unlikely front-end wants to communicate with the database cluster if you are doing that kind of thing. All right, no more questions for now. I've mentioned that you can automate your TLS and certificates with Kubernetes. This is very handy. So there is this external service called Cert Manager. It's a market standard. Everybody knows it. It's trusted. It's open source, and you can leverage it. You can leverage it to automate your TLS certificates. So you don't need to auto renew it each time by hand every time, and then forget after 1 year, and then have the TLS expire, and then the customers are met with an HTTP site, which is an untrusted connection, and so on and so on. So Kubernetes can handle that for you and can renew it for all services and ensure also internally that everything is authenticated properly. And in this example, I wrote a Let's Encrypt certificate to connect with the API from Let's Encrypt.org. And this will use ingress from Nginx. And as you can see, this will automatically issue certificates for the front-end service that we have. Next, let's go into Kubernetes Secrets. Those things basically, just like Docker Secrets, store sensitive data, passwords, OAuth tokens, keys, etc. in the cluster. They are sorted by namespace, so secrets in one namespace are transferred to another namespace. So this is good for CI/CD because when you have same name for secrets in production and same name for secrets in development, you can just roll out the CI/CD and just specify the namespace it should drop to, and just keep everything as same name within a naming standard. And containers access those values, those secret values, as mounting them as volumes or by using them as environment variables, which poses a big question. Those things aren't encrypted by default. They are base 64 encoded, which means they can be decoded. And also they don't have rotation or access control besides the airbag. So they are not very well suited for large scale or highly sensitive use cases. I've seen many people use Kubernetes secrets for large scale. I've seen live applications use that. But then again, I've also seen cloud services like AWS ECS, which deploys your Docker containers, and for example, hosts them. And I've seen people put passwords in as a plain text. So depends on what you're doing and how serious you are with your software, and maybe if you are just playing with it, or if you are hoping that no security breach comes out. Well, let's not do that part. You never know, and when a control comes, or when one of the customers or an audit comes up, well, this can spoil trouble. And as a workaround for this, you can use Kubernetes API server to encrypt them at rest, or just go the easy way and use Secrets Manager. Because an unprotected Kubernetes API server could also allow attackers to list the secrets and even create the pods with privileges remotely. So once again, cloud solutions if possible, or HashiCorp Vault or anything else. But they are fine for stuff that will like not break or is kept locally, or for testing on the development or staging. This has its uses, and this depends on your configuration. Pretty sure that when you are designing your architecture for the application, you will know what to pick. So this is one of the tools. It's not a bad tool. It just has specific use cases, and I would not demonize it just because it's not as safe as Secrets Manager. So it's basically designed for sensitive data, and maybe can be encrypted at rest, but I would prefer Secrets Manager myself. There is also something called config maps, which I have not in this presentation, but please do not use config maps to store secret values, because they are not even encoded, and they have no protections that the Kubernetes secrets have. As for the monitoring of pods And Docker, as I've mentioned before, there are many tools on the market like Falco or Sysdig. Basically, they allow you to detect any unusual, abnormal behavior in Docker, Kubernetes, and so on, etc., etc. Any weird behavior like running shell scripts or something else can be prevented. This snippet that I've included below will basically detect shell usage and then it will issue a warning, and then you can use some other tools to block this shell script from being executed. So it's nice to give clear messages to other security mechanisms in the workflow. Before I now I have some real world examples for you to talk about. So before I wrap up this presentation, because I'm not much of a presentation guy myself, I prefer talking. Let me just go into the questions. All right, so I will go into questions, and also I will give you some real world examples at this point. Feel free to ask questions now. I will answer all of them and do my best to answer each one of them. From any potential questions you may have, like benefits of multi-staging Docker images, well, as I've mentioned, they reduce the build size. They reduce the build size of your Docker images. This is pretty neat. For example, in real cases, when you use S3 and you pay, well, basically storage in the cloud, and you pay for storage, you want to keep those as minimal as possible. Also, when Kubernetes starts up, it will pull the Docker container image. And if you keep them small, it will pull them faster, use less bandwidth, you will pay less for bandwidth, and they will start up faster after a rollout of a new version. So that's a big benefit of multi-staging them, as I've mentioned, to separate build dependencies from the actual runtime. And also it minimizes the attack surface, as I mentioned. So that's for the dependencies. Another thing you may be curious about is the difference between, let's say, pod security, which I've mentioned. Let me just go a bit further here. Okay. Differences between pod security and other stuff like Open Policy Agent or Gatekeeper, which is a very nice tool on the market. It has its own uses. Basically, pod security is very simple and it's predefined. So there are some rules, they are already set. You cannot pretty much modify them other than what they represent. They're at namespace level, they're simple and they're lightweight. It's good for the job. If you don't need more than that, it's fine. But if you want to go further and fine grain those permissions, run some complex policies and enforce them across the entire cluster, for example, something I've mentioned earlier, enforce signing of signed image containers or specific labels, then you can use OPA or Gatekeeper. Wait, can I post it somewhere on the chat? I'll just request it. Okay. Matilda, can you pass the alternative to the chat that I spoke about?
Yes, sure.
Thank you, because I don't think I can join the chat. So this is what I spoke about. I see Cryptos as a question. What are common attack vectors specific to containerized applications? Well, this depends. The biggest attack vector is dependencies. So for example, you have zlib. Let me just roll up. Was it zlib? Yes. So basically, on this one, we have 17 critical vulnerabilities. And let's say one of those vulnerabilities allows for a remote code execution. So once the application, let's say the application is public, hosted on a repository in public, open source, or it's maybe sold, or maybe people can demo it or download it or check it up. They can check how it works. especially if it's on GitHub or GitLab or somewhere else where people can just browse it up, and they can see what kind of dependencies you use. For example, they use outdated glib, they use outdated zlib, and so on. Maybe this one allows for remote code execution. I see that this application uses this dependency in the outdated variant. So a potential hacker can push certain code and remotely execute it on the computer, in the Docker, to take the Docker container over and then access to the host system if the application is running in a container. This is the most common attack vector by dependencies. Let me think of another attack vector that is very common. I'm thinking about real practical applications because I will not write to you about edge cases. I've mentioned already image vulnerabilities, right? So not only dependencies, but also stuff you include there, right? So outdated Postgres, outdated MariaDB services, and anything else in there. Secrets exposure, I suppose. Docker secrets are pretty easy to expose. So if you have any passwords in there, and if somebody manages to snoop them up, you can also get those passwords, note them, and perhaps use them in some other complicated attacks on a live application or a live system. What else? Well, also unprotected APIs, since Docker daemon and Kubernetes, this is for both Docker and for Kubernetes, exposed and unprotected APIs can lead to plenty of bad stuff. So containers can be created, pods can be created additionally, or maybe the attacker can escape the containerized environment and access the host system. So pretty much those things I've mentioned here are already the most common ones. Also open networking. So when you don't, wait, where was my presentation? When you don't actually, when you don't segmentate your network and you allow everything to communicate with everything, then bad stuff can happen as well. This is one of the biggest attack vectors, network segmentation. If you don't segment, this can be misused later on. If you don't have any more questions, then I can give you a practical example of how to use this in a real world scenario. So for example, imagine you have a secure e-commerce application, right? Let's start with Docker. We want to use Alpine for minimal base image. And then we want to multi-stage this build. So we have some code to build, and then we separate those dependencies into the runtime environment. Then we sign those images with Docker Scout, and then we scan them as well, just in case there is no vulnerabilities in there. And then we use AWS Secrets Manager because we want to be serious. We don't want to use Docker Secrets for a production e-commerce application. I mean, we don't want to leak sales data or something like that. Then once we are done with Docker, we switch to Kubernetes. We create namespaces to isolate dev, staging, and production. And then we set airbag for all of them to enforce least privilege there. So access control there and define that stuff cannot do what it doesn't need to do. After we do that, we can define network policies to restrict front-end and back-end traffic, as I've mentioned before in the previous example. And then we can restrict pod security to block privileged containers. So if something happens, like one of the attack vectors that I've mentioned, somebody escalates the container and creates another container with root privileges, we can restrict that with pod security. So when that happens, it will just be thrown out and never come to realization, never happen. This is especially important in stuff that handles customer data or even credit cards and something else. And once we are done with the Kubernetes part here, we go into TLS and secrets. So we want to automate TLS. We don't want to deal with that in practice. That's what Kubernetes allows us with with Cert Manager. And we once again store, this time Kubernetes secrets in Secrets Manager. And we do that via IAM service account. So this one is a bit complex because if you want to pair Kubernetes with Secrets Manager, you need an IAM role for that and use it with OpenID Connect, and then pair this service account with the IAM role. And then you can use an SDK for example, from AWS, like Boto3 or Botocore, to pull these secrets into the application on demand rather than store them in unencrypted format, like I've mentioned before. Or you can use CLI to also fetch those secrets. Or you can use external secrets operator. That's also an option. It's the actual name of the application. So once we are done with the TLS and secrets part, we have runtime monitoring. I've mentioned Falco right here, and we can monitor every unexpected behavior what happens there. But on top of Falco, we add monitoring to the application logs and to cluster. So for this tool, we can take Prometheus. You can even take Prometheus and pair it with Grafana, and you can even pair it with Blackbox Exporter or something else. Or maybe you can just grab Sysdig, and that will be enough for you. Those all are open source tools, and once again, you don't need to pay a dime for them, which also allows you to play with your own stuff in labs and so on. And then after we set up the monitoring, we should work on the supply chain security. So generate and validate the SBOMs. So the software bill of materials that I've mentioned, the detailed components, dependencies, libraries, basically everything the federal guys and serious companies will want from you. And then after we do that, and we validate them with Docker Scout or Sift. That's another, wait, maybe I'll just write those things. Okay. I'll answer your question soon. All right, so I'll finish this practical application before I omit some details from my head. So once we sign those, once we generate and validate those SBOMs with Sift or Docker Scout, we enforce image signing using cosign. Yes, that's something else I didn't mention, because as I've mentioned, there is plenty of tools on the market. Also, please pass this one to as well. Once we enforce the signing of images, we can validate this step in CI/CD. So your DevOps guy, or maybe you personally, can do the validation to ensure they are signed in the building and deployment stage at this early process. And something I also didn't mention, but a nice practical step for you is to ensure disaster recovery. So, for example, backup your etcd and persistent volumes in Kubernetes with Velero. That's one more tool for you. This is used for backing up those things like persistent volumes, because yes, you can use some mechanism, but this is very handy. And once you have that, you can test regularly with GitOps, like Argo CD or something else. So this is a practical example of everything I spoke here. You can have an e-commerce app running on all of those things, and it will be fine out of box. You are very unlikely, if you follow those steps, to encounter any security breaches, get into any drama, or like end up on a front page of some newspaper that this much data has been leaked, 60 million users data was exposed, and now you need to hire 50 security engineers. Maybe it sounds simple, but sometimes it's not that complex to ensure good practices. And your question is to security tools for analysis of Helm charts. Well, that's a good question. That's a good question. Let me think. I use, what was the name? Well, depends what you want to do. I personally use Pluto and KubeScore. Let me just write those for you. if you could, thank you. So basically with Pluto, you can identify deprecated APIs in the Helm chart. And with KubeScore, you can evaluate those Helm-generated Kubernetes manifests for best practices. There are other tools on the market, but I think those two will be enough for your use case. Possibly. It depends what you do. If you have any other questions, feel free. I will do my best to answer you. They don't need to be related to Docker or Kubernetes. Maybe I will know the answer. I mean,
All right. If you don't have any other questions, okay, there is one more.
well, it's the hardest question that has been asked today. Well, I basically do DevOps, DevSecOps, site reliability engineering. I work on hardware. I do networks, physical, and I work on AWS cloud. In ECS and Kubernetes, I worked with machine learning applications hosted in Kubernetes cluster on using MongoDB and Postgres. Well, I manage databases. It's very hard to name my role. That's why I often introduce myself as a systems engineer, but I guess I'm a kind of jack of all trades, right? I'm not a coder. That's what I'm not. Like you guys, most of you guys will probably code way better than me. So there's that.
All right. Do you have any other questions? Okay, XD. All right, guys, if you have any other questions, you can just catch Dawid on LinkedIn. You can write to him directly. And thank you all for joining us today. Thank you, Dawid, for your presentation and answering all those questions and so on. So thank you very much. And see you next time in February, because we will have another functional world. You will have all the details on our meetup group as always, and the next meeting will be Scala related. So thank you all for joining and see you next time.
Thank you and see you.